This video is on 3 practice problems, an easy, medium, and hard, again for plane geometry, which would be section 5 of 6 for the practice ACT test. The plane geometry section covers questions which regress of topics that are usually part of high school geometry. Though some topics are introduced in earlier coursework, included are the properties and relations of plane figures, which are triangles, rectangles, parallelograms, trapezoids, and circles, angles, parallel lines, and perpendicular lines, translations, rotations, and reflections, proof techniques, simple three-dimensional geometry, and measurements concepts like perimeter, area, and volume. Justification, proof, and logical conclusions are a part of this area. Let's do the first example, which would be an example of an easy problem under this plane geometry category. What is the area in square inches of triangle ABC below? Notice they don't give you the equation. This is one problem where they assume you will understand how to remember the equation for a triangle. Area of a triangle is 1/2 times the base times the height. And in this case, our base is 8 inches and our height is 6 inches. So half of 8 is 4 times 6 is 24. So our area is going to be 24, or D square inches, or inches squared. A couple of things to remember here is that when we talk about area, your base and height always have to be perpendicular. That's why this and this and this little box here was important. We need to make sure that they are perpendicular. Sometimes they can throw you off a little bit by drawing a triangle that looks like this, where your base is more on top. And don't let that throw you, where they give you that this is 4, this is 5, this is 8, and this might be 6. Something like that. Just realize that the two that you're going to work with are the 4 and the 8, because they're the only two that are perpendicular. So just keep that in mind. That might be something they'll try and trick you with. It's just base and height always for area has to be the two sides that are perpendicular. It's kind of the same concept with a parallelogram. This would be your height. This whole thing would be your base. Just need to realize that they are perpendicular. Let's look at the next one. The radius of a right circular cone is doubled and its height is tripled to form a new right circular cone. What is the ratio of the volume of the original cone to the volume of the new cone? And then in this case, they say, you know what, they won't be expected to remember that, so they give us the equation. So in general, the volume of a cone is 1/3 pi r squared h. That's just for a generic cone. Think about like an ice cream cone. Generic cone, here's your radius. This would be our height. Again, radius, and your height is what's perpendicular. What happens though, they say, when we go through and the radius is doubled and the height is tripled. So let's go through and just redraw that picture. Here's our new cone. The radius is doubled, so that just becomes 2r. The height is tripled, so that just becomes 3h, 3 times the height. Let's take those two pieces of information, this and this, and plug it into the same equation that they gave us before, which is this one. But let's just plug it in. Volume is equal to 1/3 times pi times the radius squared, but in this case our radius is 2r squared, that's an r, times the height, but in this case our height is 3h, not just h. Multiply it out, this is 1/3 pi, 2 squared is 4, radius squared is radius squared, and then your 3h. I'm just going to combine these terms, so I get 1/3 pi 12 r squared h. Just multiplied those two. Okay, so how does that figure small cone to original cone to big cone? So I'm going to write the volume of the original, which is 1/3 pi r squared h, to the volume of the second, which is this one, 1/3 pi times 12 r squared h. And what is the ratio? Let's see what happens. The 1/3 will cancel, the pi's will cancel, the r squareds will cancel, and the h's will cancel, which leaves us with a ratio of 1 to 12. So our ratio is going to be G, our answer is going to be G in the ratio of 1 to 12. In this case, they're testing the volume of a cone where they will give you the equation because it's not something they would expect you to remember. Let's move on to a hard. And this one's not necessarily that hard, it's just a matter of do you understand what a revolution is? Through how many degrees does a wheel rotate in 1.5 minutes at 45 revolutions per minute? And you have to realize that in this case, you need to set up a proportion. Not too bad. We go through and we say, all right, there's 45 revolutions per 1 minute. And then they say, well, what happens if we do it for 1.5 minutes? So I'm going to keep the same units on the top, or excuse me, on the bottom. I don't know how many revolutions, so we'll leave that as x. Let's cross multiply and see what happens. We get 1x equals 45 times 1.5. So x is equal to, in this case, 67.5 revolutions in 1.5 minutes. So in 1 minute we did 45 revolutions. In 1.5 minutes we're going to do 67.5 revolutions. However, that doesn't answer the question. How many degrees does it go? So what happens is we got to realize, well, a revolution means it's started. It's like a bike tire. It's gone around once and gotten back to the beginning. That's one revolution, which is going to be 360 degrees. So if we go 67.5 revolutions, and each revolution is 360 degrees, let's go ahead and multiply those two. 67.5 times 360 is 24,300 degrees in total. 67.5 times it's rotated, a full 360 degrees each rotation for a total of 24,300. So my answer is A. Those are 3 questions that you might see in the category of plane geometry on the ACT.